Hey guys, welcome to the channel. Today we're gonna study about silicon controlled rectifier, that is an SCR, and in this video we're gonna understand what is an SCR, its working. We're gonna study its VI characteristics, also its working, and the end we're gonna solve some numericals. Okay, so let's start. Starting, what is an SCR? SCR is a 4-layer PNPN 3-terminal semiconductor device used for controlling or controlled rectification. Okay, so this is I have a diagram of SCR over here. It has basically 3 terminals, and it's a semiconductor device, and it has 4 layers. You can see it's a PNPN 4-layer 3-terminal power semiconductor, and it is basically used for controlled rectification. It has 3 terminals: the anode, cathode, and gate. It's a silicon controlled rectifier, and it is basically this device acts as a true electronic controlled switch. It can change AC at the same time. It can control the quantity of power fed to the load. So it basically acts as a switch, and SCR combines the features of a rectifier as well as a transistor. So an SCR is not as same as a transistor, but it has features of both a rectifier and transistor. Okay, then coming to the symbol and structure. So here I have the symbol over here, you see. So this is the symbol. We denoted the top one we call anode, then this part is cathode, then the gate. And how we make the structure is like it's a PNPN junction 4-layer. So we have 3 junctions and 4 layers. So the top one is anode. Anode attaches the P, then N, then again P, N, and gate is from the second P. Okay, so this is the structure, and there's a pro tip to remember. The structure is the gate is connected to the P layer below junction 2. Okay, so this is it. Now coming to the working of an SCR, we have 3 working mode for an SCR. The forward blocking mode, in which the anode is positive, the cathode is negative, so the SCR is generally off. Okay, and then this is also called like the middle junction. This one, the J2 junction 2 become reverse biased. Then we have a forward conduction mode, in which we applied a gate. In the gate terminal we applied a pulse signal. The SCR turns on, continuous conduction even after the gate is removed. Okay, and then we have the reverse blocking mode, in which we provide the negative to the anode, then positive to the cathode. The SCR acts as a diode. It blocks the current. I have a pro tip to remember this thing. The SCR turns on by gate pulse. In the forward conduction mode, we covered that after applying the gate pulse, the SCR turns on. So it turns on by applying a gate pulse, but turns off only when the current falls below the holding current. Okay, then let's study the VI characteristics of an SCR. So this is very important from the exam point of view. Okay, so I have this curve in the Cartesian plane, and when we look at this characteristic curve, we are tracking from anode to cathode voltage against current I, and this is our voltage, and then we have the current, and we are tracking between the voltage and current. Now looking at this horizontal line in the third quadrant, actually we're now looking at this horizontal line in the fourth quadrant. What we observe is the off state. So basically this fourth quadrant represents the off state, and the second quadrant shows the on state of the SCR. Okay, so from here the off state is generally reverse biased. So what we mean by reverse biased is that this is actually in off state. In the forward bias, the SCR is generally on. So in the forward bias region, we basically start in the off state. Even though the voltage is positive, the SCR blocks it. You notice how how this line stays flat. This shows only a tiny amount of leakage current. Okay, so the device is basically on, but still it blocks the current. It's basically waiting for a signal. If we keep the voltage pushing without a gate signal, to this part, see, we keep the voltage pushing without a gate signal, we hit the breakover voltage. Okay, from this we are not increasing the gate signal, but we are keep pushing the voltage, and this thing goes flat, and after the breakover voltage it breaks. This is the knee of the curve. You can see this looks like a knee of the like a human knee. So you say this is the knee of the curve. At this point, the middle junction, at this point, the middle junction breaks down, this part, and SCR turns on. However, in most circuit, we use gate triggering to jump to the on state much earlier. So this is a way of starting the SCR. Like you see this flat line, we are increasing the voltage. It's a forward voltage plus, so we are increasing the voltage, and there is actually no gate signal. So we can turn off by this method also, but this is a losing method. Instead, mostly what we do, we give it voltage as well, we trigger the gate, so this turns on the SCR much faster. Okay, now talking about the on stage, the forest bias state. Once you trigger the voltage across the SCR, drops instantly. You see these dotted lines, so it drops instantly, and the device enters the on state. Now it acts like a closed switch. The current shoots up limited only by your external load. Look closely at the holding point. This point. Look closely at the holding point. If your current drops below this level, I'm talking about this, this is current level. If the current drops about this level, the SCR will slip back to the off state. Okay, so this is about forward bias. Now talking about the reverse one. Reverse bias means the blockade, or say for off state. When we reverse the polarity, like we are changing anode cathode polarity, here the SCR acts like a standard diode but in reverse. This line, labeled reverse blockade, and this shows that it is successfully stopped current from flowing to the opposite direction. Yes, as I already mentioned, an SCR acts like a transistor and rectifier. So when you just change the polarity, this thing actually blocks the current from flowing in the reverse direction as a diode does. And for turning on, we increase the voltage connected to the load, as well as we have to increase the gate impulse to successfully turn it off. Or even if you don't increase the gate impulse, it will reach a certain voltage level, then it will form any, and after the breakover voltage, it will turn on, and it will rise the current as well, and after the holding current, it will again shut down instead of maintaining in the on state. Okay, then how normally a SCR works, the understanding the normal operation in an SCR. In order to operate the SCR in normal operation, the following points which I have made here uh, to be kept in the view. Okay, the supply voltage is generally much less than the breakover voltage. The SCR is turned on by passing the appropriate amount of gate current for say a few milliamps, and not just by breakover voltage. If you try to turn on a SCR by the breakover voltage method, after a certain rise, it will turn off automatically. Okay, so the way you turn on an SCR is passing the appropriate amount of gate pulse or gate current it requires. When an SCR is operated from an AC supply, the peak reverse voltage which comes during the negative half cycle shouldn't exceed the reverse breakdown voltage. When an SCR is turned off from the on state, like it's already on, but you have to turn off, the anode current should be reduced to the holding current. This is the holding current. You raise the anode current to keep it turned on, but if you want to turn it off, just reduce the anode current to this point, it will turn off automatically. If the gate current is increased above the required value, there is a certain value you can increase the gate current, but if you just increase is much more than the required value, how the SCR will react is that it will close at much reduced supply voltage. You increase the current, it will reduce the supply voltage. This is the important terms in the behavior characteristics of an SCR. Okay, In the exam, if it comes, you just draw this thing and explain this operation. You can easily get 5 marks. To study SCR, we need these following terms like breakover voltage, peak reverse voltage, holding current, forward current rating, and current fusing rating. And I'm gonna explain it in a very short way. So, what is breakover voltage? It is the minimum forward voltage gate being open at which SCR starts conducting heavily. It is the turn-on condition. Thus, if the breakover voltage of an SCR is around 200 volts, it means that it can block a forward voltage. You see, like the SCR is open as long as the supply voltage is less than 200 volt. If the supply voltage is more than this value, the SCR will be turned on. Okay, this is the breakover voltage. As I have mentioned earlier, the SCR only turns on after the breakover voltage. So if the weight over voltage is like 200 volts, it will only turn on after you increase the supply above 200. And commercially, the SCR that are available in the market have a breakover voltage range from 50 volt to 500 volt according to the application. Okay, then we have the peak reverse voltage. It is the maximum reverse voltage that can be applied to the SCR without conducting in reverse direction, in which this is for the reverse stage, the reverse bias stage, in which we interchange the anode and cathode supply. So we just reverse the polarity. Peak reverse voltage is an important consideration while connecting an SCR in a AC circuit. During the negative half of AC supply, it does act as a rectifier. So during the negative half of AC supply, the reverse voltage is applied across SCR. If the peak reverse voltage is exceeded, there may be an avalanche breaking down and the SCR will be damaged if the external circuit doesn't limit the current. So this is a thing to remember. If the reverse voltage applied to the SCR exceeds, so it will make a avalanche like thing, like it will rise and then fall, avalanche like thing, and this thing can damage your component. So you should limit this current as far as possible. This case is only possible with the AC operation. So keep in mind, for the only during the negative halves of AC supply. So commercially SCR have a quick reverse voltage rating up to 2.5 kV. That's a good one. The holding current. It is the maximum anode current, the gate being open at which SCR turns off from on condition. After this holding current, as I have shown you here, is the holding current, and this is the maximum current the SCR can handle below the on state. After this holding current point, it will turn off automatically. You just reduce the current to turn off an SCR from on state to off state. You just reduce the current in the below the holding current limit. It will just turn off. When an SCR is in conducting state, it cannot be turned off even if the gate voltage is removed. Like if the load is connected to the SCR and you want to turn it off, you cannot turn it off. Even the gate, you have the gate the holding current part, the gate pulse you remove, you cannot turn it off. So this is negative of SCR. Anyways, the only way to turn off or open the SCR to reduce the supply voltage to almost zero or negligible, at which the point the internal transistor comes out of the saturation and opens the SCR. The anode current under this condition is very small, for say a few milliamps, and this is called holding current. Uh, okay, does an SCR has an holding current of 5 milliamps, it means if the anode current is made less than the 5 milliamps, the SCR will turn off. So this is the example. Like if your SCR is having a holding current of 5 milliamps, and if you just drop the anode current less than 5 milliamps, the SCR will be turned off. That's it. Now coming to the forward current rating, it is the maximum anode current that an SCR is capable of passing without destruction in the on state, of course. And every SCR has a safe value of forward current at which it can conduct. If the value of the current exceeds this value, the SCR is going to destroy due to intensive heating of its junctions. For example, if an SCR has a forward current rating of 40 amps, and it means the SCR can safely carry only 50 amps, or say up to 50 amps. Any attempt to exceed the 40 amps threshold can result in destruction of SCR. Commercially available SCRs have a forward current rating from about 30 amps to 100 amps. Okay, and then coming to the current fusing, it is I2T rating. We call current fusing as I2T rating. So this is the product of square forward surge current. This is the product of squares forward surge current and the time of duration of the surge. So if there is a surge, for say there's a spike up. So this is square of the forward surge in the forward bias position. So we square the spike, we square the spike current and the duration of the spike current and the duration of the spike rising, and we multiply. So this time, this t represents time of duration of the surge, and here I have I. This I represents the surge forward surge current. So current fusing rating indicates the maximum forward surge current capable of the SCR. For example, say we have an SCR having a circuit fusing rating of 90 A2S. Okay, this is amps to S, and if the rating is exceeded in the SCR circuit, the whole circuit should have this rating, maximum rating of 90 A2S, or it have to maintain this rating. And if it exceeds the SCR circuit, the device will be destroyed due to excessive power dissipation, heat, and how you should remember the whole thing. I have a pro trick for you. Just remember, the latching current is always greater than the holding current, IL greater than IH. Now, looking at the important parameters we use in an SCR, the VVO, which denotes the breakover voltage. Then we have the IL. Just now I said it's a latching current. Then IH denotes holding current. Then we have the dVdt. It shows the rate of rise of voltage, and the didt shows the rate of rise of current. These are the short form. These are the parameters we use. That's the important thing over here. The SCR false statement, in the many previous exams, even in the previous in question paper, I found that SCR false statement often comes from this two, the latching current and holding current. Okay, so keep it in the mind and just remember what this parameters means. That we have discussed the turn off and turn on method. Now simplifying those two for easy remembrance. The turn on methods of an SCR are, of course, the most common one is the gate triggering. Then we have the forward voltage triggering and the DVDT triggering. Even in SCR, the temperature triggering also turns on the SCR. For turning off, that is a commutation method, we use line commutation and force commutation. And what are line commutation and force commutation? You can just check in the electrical for you page. There it's given in a very short and cool way, so you can always check out that. So SCR works like a switch. Off means yes, open circuit. Close circuit means on. If you turn on the SCR, it will close the circuit. If it's a switch, right? So if you turn it off, it's open the circuit. Basically this SCR is used in controlled rectifier. Also it's used in for speed control of DC motors, for say the BLDC motors. Nowadays is comes the remote control BLDCs for our home application. CRs are used in battery chargers, inverters and light dimmers. Okay, so let's solve some question. So let's start this one. An SCR has a holding current of 8 milliamps. The anode current is 10 milliamps. State whether the SCR is on or off. It's really simple. Just use the JAB Diaries exam shortcuts. You see, I have this point. If the IA is the anode current is greater than holding current, the SCR stays on. From this, you can directly say the anode current it is 10 milliamps, the holding current is 8 milliamps, and of course 10 milliamps is greater than 8 milliamps. So this is SCR is on. Okay, very simple. I am making it simpler using tricks, so you can solve it in the exam. And if you want the descriptive one, then you can just do it like this. IA equal to 10 milliamp, then IH equals 8 milliamps. Since the anode current is greater than holding current, the SCR is on. You can do it like this also. It's a very simple question. Then coming to the next, here the question says the latching current of an SCR is 25 milliamps. Immediately after triggering the anode current 20 amps, will the SCR remain on? So this is a very basic question as well. I'll show you how. So we have the latching current IL, that is 25 milliamps, and immediately after triggering or say like turning it on, the anode current becomes how much? 25 milliamps or 20 milliamps, sorry. Nice. So from the Diaries shortcut, we know you follow this one, this shortcut, like the SCR stays on if the anode current is greater than the latching current. Okay, if anode is greater than latching current, then the SCR stays on. Here you see anode is 20 and latching current is 25. So anode is smaller than latching current. That means SCR turns off, vice versa of this one. So SCR stays off. Now coming to this question, if SCR has latching current of 30 milliamps and holding current of 15 milliamps, after triggering the anode current rises to 40 milliamps and later then it drops to 18 milliamps. State the condition of SCR in both stages. The question is asking about these two stages, before triggering and after triggering stages. Okay, so looking at the question, we can make it two stages, like for say like in the stage 1, before triggering the SCR, what it is given is the IA, the anode current rises to how much? 40 milliamps. Okay, after triggering the anode current rises to 40 milliamps, and then the you see the 40 milliamps is greater than the latching current which is 30 milliamps. Holding current is greater than latching current, that means the SCR is on. So we say SCR is on. In the stage 2, here we see the anode current later drops to 18 milliamps. So say 18 milliamps, which is greater than the holding current, that is 15 milliamps. So SCR is still on. Okay, now taking on another question, this numerical, what the numerical says, an SCR is connected to a 200 watt DC supply through and 20 ohms resistor. The SCR forward drop is 2 volts We have to calculate the anode current when the SCR is on. Okay, so from the question we see the voltage across resistor is 200. See the 200 volt minus, and the forward voltage drop is 2 volts. So 200 minus 2, it's a 198 volt. This is the voltage across the resistor. Now using our dear Ohm law, it's Ohm's law. Now using Ohm's law, we get IA, that is anode current. It is current, the simple current, VYR, current equal to VYR. Here we are counting for anode current VYR. We have voltage as 198 and the resistance we have is 20 ohms. From here we get IA equals 9.9 amps. Okay, so this is the anode current is 9.9 amps. Now taking another example, the SCR has a holding current of 12 milliamps. It is supplied from a 100 volt source through a 5 kilo ohm resistor. Determine whether the SCR will stay on. For this, first we have to find the current. We have from the question only, we have the current, the holding current, that is 12 milliamps, and we have to find the current that is supplied from the source. Okay, then we can compare that current, the supplied current, with the holding current, and we can find whether the holding current is greater or smaller than the current through the circuit, that is the supplied current. This will ultimately decide whether the SCR will remain on or off. Okay, so I will not solve this question. You answer me this, the result of this, in the comment section, or you try to solve this. Of course, you can find the answer in the Discord. Also, I have attached an master MCQ guide with solutions with this video. You can find the link in the description, the pinned comment, or in the drive link. So just you can look at that. I'm uploading that file also in the Discord. So if you are not yet joined my Discord, you can join that from the link in the description. So this is it for today. I hope you enjoyed SCR.